Coming up on this special edition of INTV, we find out why hydrogen is the fuel of the future. We discover just how it works and dispel a few myths along the way. Runcorn has long been a centre for electrochemical technology. We explore its future. We're on a journey to find out how far down the road hydrogen vehicles really are. Could this clean-burning gas soon be heating our homes and fueling our businesses? We head to Scotland to find out why carbon capture is key to the success of hydrogen. And we finish in Strathclyde, where industry and government came together to discuss decarbonisation across the UK. All this and more from across the INEOS Group. This is INTV.
Hello and welcome to INTV, this time from the home of electrochemistry in the UK, Runcorn. And this month, I'm joined by our communications manager, Ursula Heath, who's normally behind the camera. So welcome to the other side, Ursula.
It's great to be here, Tom, especially to be out on site where all the action's happening.
Well, it's great to have you. Now, in this episode, we hope to fuel your interest with something that INEOS has been using and producing for decades: hydrogen.
We believe that hydrogen will revolutionise the way we think about energy and help us all move towards a cleaner and more sustainable future.
Around the world, nations are striving to meet their zero carbon emission targets. To do this, they will have to reduce their dependence on fossil fuels.
If the wind is blowing, you can have wind. If the sun is shining, you can have solar. The issue is really about intermittency and storage, and it's very difficult to store energy.
A lot of people think that electrification is the answer to everything. There are many areas where electrification, at least for now, is not the answer. It won't do. And hydrogen can solve quite a few of those.
Hydrogen, the first and most abundant element in the universe, can be a great source of non-polluting energy, which can be stored and transported, and when burned, it just emits water vapor.
Hydrogen is a great material in that it can fuel your car, the ferry you ride on, the train you ride on. It has the opportunity to replace fossil fuels. It's very versatile, and therefore it will play an important role in the future.
INEOS is Europe's leading user of electrolysis, a process which can be used to split water into oxygen and hydrogen. And when powered by renewables, it produces emission-free green hydrogen. At its plant in Rafnes, INEOS is building Europe's largest green hydrogen electrolyser, powered by 20 megawatts of renewable energy.
In Norway, we have access to clean electricity, so the starting point to make green hydrogen is there. It's a great project, 22,000 tons of CO2 emissions reduced every year once it's online.
As part of the €3 billion investment into Project 1 in Antwerp, the plant will transition from its energy use from natural gas to wind power and hydrogen as a fuel source.
It's a shining example of how new technology, with a will by the company, can actually pull out the use of natural gas and replace it with hydrogen. We have a road now with hydrogen to get all the way to zero.
There are similar stories across the business, such as at Grangemouth, where INEOS is spending £1 billion in the site's transition to hydrogen power. Investment in low-carbon assets will be crucial to the energy transition. This will be supported by the recently launched Hydrogen One Capital, London's first fund dedicated to hydrogen projects.
It will create a lens for INEOS and INEOS Energy on areas where we start to see progress in hydrogen going forward, and some of the jurisdictions where we think it will become effective and allow us to invest.
But developing a hydrogen economy will require investment in infrastructure and policy changes at a national level.
What government needs to do, in a nutshell, is to help us with the infrastructure on this process, give us the ability to develop this technology at scale and push hydrogen into the economy.
It is clear that we have the know-how and knowledge of how to do this. We just need to act sooner rather than later.
So we know that hydrogen has a great future, but it also has a long history. In some minds, it conjures up something more volatile. So let's take a look at some of the basics behind how it works and maybe dispel a few myths along the way.
Water. One atom of oxygen bound with two of hydrogen. Oxygen, we know well, the giver of life. But what of hydrogen? Hydrogen is the most abundant chemical substance in the universe and the human body. Stars are formed mostly of hydrogen, ever combusting, urging life on. For animals, for plants, enabling cycles to complete. But there's a problem. Hydrogen has gained a bad reputation. Images are powerful, but the reality is a lot less dramatic. When employed, hydrogen can be used like many traditional fuels, with one major difference. It burns clean, without pollution. Oil, gas and coal all release CO2 into the environment when burned. But hydrogen's only emission is water. We have the technology to reclaim this force of nature. We can harness this renewable power from water to electricity to water. Using renewable energy to power electrolyzer stacks, we make green hydrogen through the power of electrolysis. Water flows into a chamber containing both anode and cathode electrodes. A direct current charges each pole. Oxygen is drawn towards the anode, while the hydrogen is formed at the cathode. Each can be stored for a wide range of uses. The hydrogen can be used as fuel for vehicles. It can bring power to our homes and even industry. At the heart of a hydrogen vehicle is the fuel cell. Inside, hydrogen protons are drawn through an electrolyte membrane to merge with oxygen. The electrons flow through a circuit to produce electricity. This is what powers the engine. The chemistry is completed when the electrons connect back with their protons and combine with oxygen to form water. We can now have the convenience of a fuel with zero carbon emissions. This technology we have. Now we need the scale. INEOS is investing £2 billion into green hydrogen. It's now up to government and policymakers to play their part on this clean journey. It's a change we have to make if we are able to achieve net zero by 2050, or sooner in Scotland and Germany. Viable energy production. No pollution. Just water. Hydrogen, the water former. So the cycles can continue.
For over 100 years, Runcorn has led the way in electrochemical engineering. It's of significant importance because something they make here keeps 98% of the UK's mains water safe to drink. Let's take a look.
Runcorn has been a centre of the electrochemical industry since that industry first started, and expertise has grown up around here for well over 100 years. So this part of Cheshire, because of the heritage with the chemical industry, the economy has really been based around the chemical industries for very many years. ICI, INEOS and other organisations around this area are based upon chemicals. And so I think the local population, the local people, have a pride in that as the UK's chemical industry centre.
What makes the site unique is that we are ideally situated, both logistically and geographically, close to the brine fields, which provides the essential raw material, the electrical infrastructure to produce the chlorine that we make. And that chlorine is used to purify water. 98% of the water in the UK is purified using chemicals from Runcorn. Chlor-alkali is at the absolute heart of that manufacturing process. INEOS has got a range of different businesses here. There's Innovin and there's also INEOS Electrochemical Solutions, which is a sister business. They manufacture the technology that we use in our manufacturing process.
The electrochemical industry is very important because it's really the heart of chemical technology, in particular the chlor-alkali industry, where we sell many of our products. IES produce electrochemical solutions for clients all over the world. We develop electrochemistry on an industrial scale and then manufacture machines, electrolyzers, which are the machines that carry out the electrochemistry in the large factories, and also especially the coatings that goes onto those machines. Coatings go on the electrodes inside the electrolyzer, and the function of the coating is to make sure the electrochemical reactions are done as efficiently as possible and the power consumption of the electrolyzer is as low as possible. In a chlor-alkali electrolyzer, which is the mainstay of our industry at the moment, we pass electrical current through sodium chloride brine, which forms chlorine, caustic soda and hydrogen. At the moment with chlor-alkali, the hydrogen which comes out is a byproduct, and traditionally in the industry it is either the chlorine or the caustic soda, or both, that industry requires.
The production of hydrogen is something we're familiar with, the storage, the transportation. These are all areas of expertise that we have within our business and have had for many, many years. So we make several thousand tonnes of hydrogen per year. Primarily we'll use it as a fuel in our own boiler plant. We've been burning hydrogen as a fuel for many years, very conscious of the positive impact that has. But we also have other uses where we will supply to customers downstream by pipeline, primarily for the use of hydrogen peroxide. But we also compress hydrogen up to about 250 bar for distribution throughout the UK for a variety of applications.
The same skill sets that we have to produce electrolyzers and electrochemical solutions for chlor-alkali, for example, are exactly those that need to be used for the development of hydrogen technology. And so what we have in terms of the machines only need a very small amount of change to be able to use for hydrogen technology, but especially the expertise that we have in developing technology is the same expertise to develop hydrogen.
Having IES alongside us here at Runcorn is just amazing, and that relationship is really close. We can work together on developments, on testing out new innovations.
So at the moment this site is a chlor-alkali site and produces hydrogen as a byproduct. What's particularly exciting going forward for the future is having what we call first intent hydrogen. So we will have chemical plants here using electrochemical technology that make hydrogen specifically for hydrogen production. And the uses of that into the economy going forward is really the basis of the future of the site.
I think we're at an exciting point in the history of Runcorn. We are looking forward to how hydrogen can transform us here for the future, and being able to manufacture hydrogen here really puts Runcorn on the map, not just in the UK, not just in Europe, but also across the world.
It's a neat symmetry now that as we go into the 21st century, that we see hydrogen taking more and more a role in cleaning up the environment. We still provide caustic soda for the soap industry, by the way. Runcorn has been for over 120 years a cornerstone of the UK economy, and it will continue to be so going forward.
Many people believe the future of transport is electric. However, it has its limitations, such as range, charging times, and battery size. The answer to this could be hydrogen, which is already fueling some cars, buses, trucks, and construction vehicles. We've teamed up with Wrightbus to take our own hydrogen-powered double-decker around the country to meet with businesses who are becoming part of the new hydrogen economy.
The future of fuel in transport is a big question. One answer to this could be hydrogen. And to demonstrate its viability, INEOS teamed up with Wrightbus and Rise for a bus tour that took them across the UK, visiting businesses working with hydrogen, all the way to Glasgow for COP26.
The ambition for the tour is really to showcase that hydrogen can play a major role in decarbonising our economy. Partnering with Wrightbus has been the right thing for us to do here. We can provide the hydrogen, Wrightbus can provide the engine that can consume it, and together we can then show that this is a very viable option for heavy-duty transport like buses.
This is our first double-deck hydrogen bus released to the UK market last year. We've got two main customers already operating it. One is in Aberdeen and the other one is Metroline in London. If you look at car industry, mainly have already gone towards electric. But the bigger, the heavier use, you actually find that there needs a lot more energy and therefore batteries just don't do the job for the more arduous journeys. So the longer bus routes, the transport around moving goods and food around the country, you'll see more towards hydrogen.
We have over 100 buses on the roads in the UK today. We hope to do more. There's 45,000 buses in the UK and it would be great to decarbonise most of them. You can't get to zero emissions without hydrogen. Hydrogen is a wonderful storage mechanism. You need them all. You need batteries, you need hydrogen, but hydrogen works very well on big storage and it operates in a similar manner to diesel or petrol.
The difference between a hydrogen fuel cell bus and a battery EV bus is this tank stores hydrogen. The hydrogen is converted by a fuel cell underneath here into electricity. And that electricity runs and drives the motors on this bus.
And it's not just buses making use of this technology. INEOS Automotive have announced they are developing a hydrogen fuel cell version of their new 4x4, the Grenadier.
Hydrogen is absolutely the right application for a vehicle like the Grenadier. With a hydrogen fuel cell setup, we'll be able to offer the same sort of a range as the internal combustion engine, while also being able to fill up as quickly, so no plugging in for long periods of time. Grenadier is a tool, it's there to do a job, so customers need to have that ability to get out there and do it and not be compromised in their application by having to park up and recharge.
With this tool, we would like to create awareness for hydrogen, because hydrogen to the wider public is not very well known. And it is important that people know that hydrogen is a powerful gas with a lot of energy, but without CO2 molecules. So it can do the same as natural gas, it can do the same as fuel, but without emitting CO2 to the environment.
And it's not just our roads, but the skies above that could be transformed. One of the first stops on the tour was a visit to hydrogen aircraft manufacturer Zero Avia.
Zero Avia started about 4 years ago in California. We were the creator of the largest and the smartest platform for electrical vehicle charging. And then after we sold the company, there was a question about what to do next. You know, it was quite natural progression to actually start something in aviation. After we did all the calculations, it turned out that hydrogen is the only scalable solution.
We believe the combination of an electric powertrain plus hydrogen and fuel cells are the best solution for aviation. From an energy density point of view, compared to competing technologies like batteries, we believe hydrogen has the advantage. We've got a fuel cell test lab on site that allows us to test the full power of the fuel cells and do a lot of developmental, experimental work prior to installation onto the aircraft and subsequent ground testing followed by flight testing.
We believe in practical incremental approach. For the last 2 years we worked on the 6-seat airframe. So we started with the battery electric configuration. Then we have flown 100% on hydrogen. And now we are moving to the 19-seat aircraft.
Fuel cell testing is going very well. We've had the successful flight test in the Piper. We're really looking forward to testing the system in the Dornier in the coming months.
So we are anticipating the introduction of this technology into commercial space in 2024 when we finish testing of this engine and then certifying it in 2024, 2025 when you will see the first commercial flights using hydrogen electric powertrain. It is important to create awareness among public and all the other stakeholders that hydrogen is safe. Hydrogen can be used in all types of transportation and all types of application in a safe manner.
Changing the way we get around is important, but construction also depends on large vehicles, so reducing their emissions is vital to building a better future. And who better to speak to than the company synonymous with building?
So JCB has been working on its Road to Zero, its plan, or our off-road to zero as we call it, for some time. We've been looking at all different solutions. We've got a number of solutions in the marketplace already today, but we're really excited about hydrogen. It's the perfect solution for our industry, where we've got machines isolated in remote locations, created infrastructure for the first time. Perfect, because it's a mobile fuel. We can deliver it to site. We can allow machines to keep working, take the hydrogen to site to fuel machines. I think without question, this technology is the most suitable for our industry. You know, customers say to us, create great new machines, but please make sure they're not too complicated or too expensive for the market they serve. But actually coming up with a hydrogen fuel motor, hydrogen that's taken and put through a combustion type engine is the perfect solution for our industry. We're really excited. There seems to be more and more large companies getting involved, fuel companies, gas companies deciding to move away from that and move into green hydrogen solutions. We've got great engineers making electrolyzers now, tying them to wind turbines, to solar panels. So there's a great opportunity to pull all the network together and really have a fantastic supply of hydrogen. But we need to give people confidence that the solution's correct. Come and experience it. The roadshow is just another fantastic way of endorsing the technology, but more importantly, making people aware that it's just a great solution to get to zero CO2 quickly.
To make the hydrogen economy happen, further technology is required, but it also needs infrastructure and producers to make the gas. INEOS's Innovin site at Runcorn was one of the stops on the journey, where investment into hydrogen production is already underway.
This is an exciting time for Runcorn site. As lots of industry has changed its form over recent years, here we are producing hydrogen and can produce more hydrogen that can feed and support the UK in its drive for net zero. INEOS has announced €2 billion across the world in developing hydrogen technology. Here in the UK, we're seeing tens of millions being invested on our site to enhance our compression, our purification of that hydrogen to a standard that is suitable to feed into transport networks.
The future of hydrogen is absolutely huge. The number of applications that are being developed for hydrogen, with the environment in mind of course, are almost limitless, but they're absolutely massive in terms of volume. So really the sort of industry we work in will be transformed as hydrogen production becomes absolutely fundamental.
Industry is ready and willing to invest in this infrastructure, but it needs the right framework, the right business models to make it happen. But as a customer, you're not going to buy a hydrogen fuel vehicle or a hydrogen boiler if the supply of energy isn't there. So to join the dots and bring the suppliers and the customers together, you need the right business framework and you need support from the government.
After touring the country and visiting many different locations and businesses, the final destination was Jordan Hills School in Glasgow. Kids got to see close up what future journeys to school might look like.
I think they've just been so excited from when they found out that they were going to get to go on the bus. They know that urgent action is required, and they see it on the news all the time. So let's take a view to empower pupils and also to give them hope. So what they see often is the negative side of things, but they don't quite often see the solutions. And that's why today's visit has been excellent. It's showing that solutions aren't just on the horizon, they're actually here right now.
Roadshow is there to inspire this next generation. Coming here is talking directly to the pupils about what we're planning to do, and it's not just about the bus. These guys have to understand that in rail, in shipping, and in aircraft, and in construction equipment, over the next 20 or 30 years they will see hydrogen more and more as a power source for these vehicles, and it'll be fantastic for them when they come through their apprenticeships, through university. There is no doubt the hydrogen economy will touch these kids, and that's a very positive thing for the future.
As we've seen, we can't create a hydrogen economy without bringing other businesses who share the same ambition together. HyNet is just that, a consortium which aims to bring the benefits of hydrogen to the Northwest.
HyNet is a collaboration of industry, politicians and academics seeking the development of the hydrogen economy across the northwest of England to reduce the amount of carbon emissions coming out from industry and our households.
The corridor that we operate in here represents something like 3% of the UK's total energy, so that's very, very significant.
HyNet could reduce the carbon footprint throughout the whole city region by 25% per year. And that's about 10 million tonnes of carbon that would be emitted into the atmosphere.
The key partners of the HyNet consortium include carbon emitters such as CF Fertilisers and Hanson Cement, hydrogen producer Essa Oil, Cadent, the gas distribution company, and INEOS, who will provide the hydrogen storage. So, how would it work? HyNet is a project that combines hydrogen production with carbon capture and storage. Natural gas will be converted into blue hydrogen, and the carbon dioxide byproduct will be removed. This CO2 will be combined with carbon captured from other industrial processes in the region and safely stored into depleted gas reservoirs in the Liverpool Bay. The hydrogen will then be distributed via a new network of pipes to industries as energy and feedstock, local authorities and transport networks, and in time, it could be used to provide heat and energy to homes across the region. INEOS's role in the scheme is to provide storage to balance out the supply and demand for hydrogen. At a storage site in Cheshire, INEOS is testing the viability of storing hydrogen in old salt caverns.
As part of the HyNet project, we're developing a 19-cavity storage project capable of storing 1.3 terawatt hours of hydrogen. Each cavern is about twice the size of the Albert Hall and is capable of storing about 50 gigawatt hours of energy, which is roughly 50 times the largest lithium-ion battery storage project in the world today, which will allow the HyNet project to balance the supply and demand of hydrogen to its customers.
Hydrogen is the battery when it's stored. So when you've got generation of gas, when you're not using it, the sensible thing to do with that hydrogen is actually to store it. Now, when there is excess demand for that hydrogen and you're not producing enough, then of course you can draw upon that source to distribute to industry, to households, to transport.
Hydrogen's a very safe gas. In much the same way as natural gas, it needs to be kept in the pipes and used responsibly to heat our homes, to allow us to cook. And the same applies for commercial operations, shops, businesses, factories. They can all use hydrogen in much the same way as they use natural gas.
The initial market for the hydrogen will be local industries like Encirc, a company that manufactures 40% of the UK's glass bottles, requiring a lot of carbon producing energy to fire their furnaces.
We take in raw materials. We take in also a lot of recycled glass that's being collected and reprocessed locally. We then need to put those materials in a furnace. They are in the furnace for about 24 hours before they come out as a new glass bottle. And during that period of time, we use a lot of energy in the process. The big challenge that we fully recognise is how we decarbonise our carbon footprint. As an industry, we've looked at many alternatives over the years. We think hydrogen has great potential to replace natural gas in our furnace. We don't think it's the complete panacea. So our plan is that we would increase the amount of electrification we have in the furnace. We would seek to replace as much natural gas as possible with hydrogen.
And it's not just industry who will make use of hydrogen. Liverpool City have ambitious plans for decarbonising their bus network.
We're putting hydrogen infrastructure into all 6 districts of the Liverpool City region. And then later on in the year, early next year, we'll see our hydrogen buses come on stream. We've got really ambitious plans with central governments to look towards a fleet of about 2,000 hydrogen buses. These are zero emission buses, so for those corridors in the Liverpool City region that have got air quality issues, these are the exact solution to the problem that we face.
In October 2021, HyNet Northwest received UK government backing and is now in the final stages of planning and consent and aims to have hydrogen flowing to customers by 2026.
HyNet is important to the region to allow industries to continue to operate in a low carbon future.
We're really excited about the opportunity that hydrogen presents. Our target is that we could reduce by at least 80% on one furnace. I think that if we could employ carbon capture technology, for example, could we be carbon free on a furnace for the first time in the history of glass?
I think HyNet's probably the most exciting project that's come across my desk in the last nearly 4.5–5 years. This is something that we can achieve and would have a huge beneficial effect on the air quality, on climate emergency, on reaching our targets to be net zero carbon by 2050.
This is of global significance. It is an absolute game changer in terms of removing carbon and transitioning away from using fossil fuels. If we can substantially reduce our emissions, in my generation, I will feel much better about passing on a world that's much better.
When producing anything, even hydrogen, we have to ensure that we do it in a sustainable way. We can't stop all CO2 emissions overnight, but we can dramatically reduce them through advances in carbon capture and storage.
Just behind me here, you'll see this blue box. That is our combined heat and power plant here at Grangemouth. It's the workhorse for the plant, making the power, the electricity and the steam that we need to keep our businesses running here at Grangemouth.
Combined heat and power plants are some of the most energy-intensive parts of any chemical site, so ensuring that emissions are dramatically reduced will be essential to INEOS's sustainability commitments.
So, up till now, we've actually reduced emissions quite significantly. Since 2005, when INEOS took over the Grangemouth site, we've reduced emissions from 5 million tonnes a year to 3 million tonnes a year. And we've done that by a variety of means. The main one has been by converting from burning oil to create our power and steam and to burn natural gas.
A new £1 billion investment in the site at Grangemouth will see the building of a new power plant.
On its own, it'll save 150,000 tonnes a year of CO2, and it'll do that by basically using modern, up-to-date technology and replacing one of the older power stations that we have here on site.
The real carbon saving will be when power plants switch to hydrogen.
Once the supply of hydrogen is available, then the plant will be modified so that it can burn hydrogen instead of the natural gas that it burns today.
Across the group, there is a commitment to green hydrogen. But for a site the size of Grangemouth, the volume of energy required won't be available from renewable sources for many years. And that's where blue hydrogen comes in.
Blue hydrogen is made from natural gas. And natural gas has carbon and hydrogen in it. And what we do is effectively split the carbon from the hydrogen. The hydrogen is the blue hydrogen. The
the carbon is converted to CO2.
So during the process of producing blue hydrogen, we do produce CO2, but it's in a concentrated form, which makes its capture considerably more efficient. The efficiency of capturing it is about 95%. Of course, we're going to have to take the carbon and transport that. INEOS has a track record of delivering big, bold projects like the ethane importing the virtual pipeline from the States. But this challenge is so great, we can't do this all on our own, which is why we need to be part of the Scottish cluster. And that means working with companies like Storega.
So the Scottish cluster unites our industries, businesses, government and communities because we've all got this shared goal. We need to decarbonise our industries. We need to make them sustainable into the future.
As part of the Scottish cluster, Storega have a plan for taking on all of Grangemouth's captured CO2.
We're putting the gas into existing pipelines that were used for natural gas coming onshore, but now we're using these pipelines to put the carbon dioxide offshore. You're talking about 100 kilometres offshore and then 2.5 kilometres deep under the seabed. And we're looking to inject the carbon dioxide gas in the sandstone rock. Now, on top of that sandstone rock, we've got layers of a mudstone or shale, which is just thick layers of rock with very, very little pores, so no spaces in between the rock. And that means that the gas can't rise up from the sandstone rock. It hits the mudstone or shale, and it means that it can't go anywhere. So there is safe, permanent geological storage of this carbon dioxide. And it's the exact same geology that has held gas and oil in these rocks for millions of years. And because of that active oil and gas industry, we know that these rocks are really great for storing CO2.
So once we start burning hydrogen on the CHP behind me, that will enable us to produce steam and power for our own consumption, which will effectively be low carbon and will reduce the footprint throughout the site wherever we use steam and power at the moment.
So today we make around 3 million tonnes of CO2, and in the next few years the blue hydrogen plant will enable us to take another 1 million tonnes a year out of those emissions.
With access to blue hydrogen, INEOS businesses across Grangemouth will be able to reap the benefits of low carbon production.
Well, this will mean for our customers that we'll be able to pass on the benefits of a low carbon product, and with the support of government we'll be able to do that in a way which remains competitive in the global market. So our plans are that we will see the transition to hydrogen use in Grangemouth by the end of this decade, so by 2030.
Once we have the hydrogen here, it'll act as a magnet for other companies. They'll want to come here and try and use that hydrogen as well, so that to reduce their own CO2 emissions.
A recent government funding announcement excluded the Scottish cluster from initial funding. However, those involved remain positive for the future of the project.
We're currently just trying to understand the impact of the recent government announcements about being a reserve cluster in the UK government funding programme. But this is too important a project to stop.
We are still committed to delivering this change and this step in our roadmap. It might just adjust the schedule slightly.
Despite the current focus on blue, Grangemouth still has a roadmap to eventually switch to green hydrogen.
Green hydrogen is very important to INEOS, and INEOS is committed to a green hydrogen future. We're using blue hydrogen as a stepping stone on the way to that.
This October, some of the brightest minds came together at Strathclyde University to discuss the important role the chemical industry will play in the energy transition to net zero.
Well, hello, and we're delighted that you've all joined us for this important event here at Strathclyde University. It's an event jointly hosted by the university and with INEOS. This is a unique event, and we've brought together a really compelling combination of senior panellists to join the conversation, each of whom has a distinctive voice in the challenges and opportunities of the chemicals industry towards net zero.
So I don't think people are any longer arguing about climate, it's really about what we're going to do about it. Economic growth and energy growth are inextricably linked to population growth. What is clear is the way in which we've supplied that energy historically over the last 260 years will have to change for the next period of time. We're going to need a multiple series of solutions to solve climate change, and renewables is important, but oil, gas and fossil fuel in the future mix and the carbon capture with that will be equally important if we're going to get to net zero.
In fact, for the past 3 decades, industry's been working very hard to decarbonise its operations, its plants, in terms of its direct scope and its direct emissions as well. For the chemical industry, delivering net zero cannot be overstated. Whichever part of the business I talk to, whether it's the leaders, the management, the workforce, today's workforce and tomorrow's, they are in it together. They want to deliver net zero, not just today, but have done so for years as well.
We've got trade unions, academia, government, business all working together to address this very important issue, as Brian has outlined, and what we can do to work in partnership to take that agenda forward. And Scotland recognised the importance of the chemical sector, both to the economy but also very much to the products it produces, and Brian's outlined the centrality of many of those products to the work we need to do in the transition to net zero.
We need a plan. And we need a design. And what's been missing from the UK for arguably 30 years has been an overarching energy policy in Scotland and in the UK more broadly. I think there's that awakening now that we need a strong partnership between industry, and that includes companies such as INEOS, of course, with public sector agencies, the investment community, because we mustn't forget this is going to cost a lot of money in the energy transition, and of course the academic sector. The UK has an outstanding academic base.
Emissions in the UK have dropped enormously over the past number of decades. But the truth is we have been involved in a form of industrial disarmament. We have been offshoring jobs, offshoring carbon production. So we've offshored work and we're importing virtue, and that has got to stop. If we are serious about dealing with climate change, we need to start bringing the work home, and politicians are going to have to face up to that reality.
There's a lot of anticipation around what may or may not get agreed around COP26, but I think it's going to be crucial to set the agenda going forward, because the world has moved on and said that we now need to start to tackle these problems going forward. Hydrogen, having sort of looked at this mix of 85% fossil fuel, oil, gas, coal, and renewables, not even if you grow them at 300%, they can't solve this problem of the population growing and needing more energy. Hydrogen would appear to be able to give us a major step forward, but we need the regulatory framework and the incentives in place to encourage the investment that will come.
You're right, we're on that transition to green hydrogen, and the electrolysis technology such as INEOS has, and you see some very big commitments in France, for example. I've been involved in recent seminars with the government officials, big, multiple hundreds of megawatts plans over the next couple of years to many gigawatts. Now, just now, in the UK energy strategy and the Scottish Government's hydrogen strategy, we're looking at 5 gigawatts by 2030. But it could be more, but it'll only happen if we've got that plan, if we've all got the understanding of how we integrate the great knowledge in companies like INEOS within the oil and gas industry generally, and then how we use hydrogen, because as an electrical engineer, I smile sometimes that we often just think about sources like generation and end use. We forget that something has to connect in between, like the networks for me in electrical systems. We need to put in place the plan and the phasing to do that. 2030 for me is a massive milestone. If we're not well down the track towards decarbonising, then we will not achieve these laudable but challenging objectives that we've laid out.
I think that's a great point to bring our conversation to a conclusion today, which is that it's about the combination of thinking, acting, and then tracking trajectory towards net zero, be it in 2045 or 2050 or any period in between. So thank you very much indeed.
The focus on hydrogen has really sparked the imagination of people here at INEOS. So let's see what other stories there are from around the INEOS group.
INEOS Hygienics have launched a new sanitizer range designed for use in sports and developed using the expertise of the INEOS sports teams.
Our INEOS Sports Sanitizer product is the only sports dedicator sanitizer product on the market. There's nothing else out there that does the same job. and it's been absolutely developed by the best of the best, the elite sports guys.
Way before COVID, hygiene was a real big part of the athlete's daily routine. It was a big concern, and a lot of work was done, or has been done over the years. And so you'd like to be able to think that all of that information about what's in the product, where do you use it, how do you get it to where it needs to be at the point of sweat, is all combined. So by sport, for sport really.
One thing this product does offer is its hands and surfaces spray, and the point of that is before you go and use a sporting bit of kit, you don't know who's used it, you don't know what's on it before, and you do want to keep yourself clean and healthy, so you can use it to spray down equipment and kit as well as hands, surfaces and everything.
INEOS Team UK will be competing for the America's Cup under the new name of INEOS Britannia as the official challenger of record. And this time, the team will join forces with Mercedes Formula One, bringing on board their Chief Technical Officer, James Allison, to advise as they prepare for the next competition. Sir Ben Ainsley will skipper the crew once more for a record-equalling third time, as they bid to be the first British team to bring the cup home.
And that's our show for now. We hope you've enjoyed yourselves. Have you?
Absolutely. There's a lot going on and so many exciting projects coming together to kickstart the hydrogen economy.
And we'll keep you in touch with all of them. So all that's left for us to do is decide who drives home.
I'll drive.
See you next time.
Bye.